Hey and welcome! Today we will solve number of islands interview problem, which mostly asked by Amazon as well as some other companies like so. We will explore both breadth first and depth first searching solution for this problem. So without further ado, let's dive in. First, let's see some examples. For example 1, we have this grid of zeros and ones. As you can see from output, we have one island here, only one set of ones that are connected to each other. Second example, we have 3 as output, and as you can see, we have 3 sets of ones that are connected to each other. So we need a way to connect ones together and count them. Let's see how we are going to solve this. Here is our second example, which we had distinct islands. There are 2 parts for this solution: finding islands and connecting adjacent islands together, only in vertical and horizontal directions. Finding islands is pretty much easy. We just need 2 nested for loops in order to gradually scan the 2D matrix we have here, and whenever we hit a 1, that means we found an island. Like this case, we find a 1 in a very first iteration. But the most important part to this problem is, what are we going to do when we find an island? And if there happens to be some neighbors to it, how we are going to know that they are connected to each other? So for that, we are going to need a bit of knowledge about some special searching methods. In fact, this leetcode problem is a good starting point to learn those concepts, commonly known as DFS, depth first search, and BFS, breadth first search. These searching methods have been tremendously used in tree-shaped data structures like binary tree, trie, or node-related data structures like graph, and so many others. But how is this search flow? So what is DFS search method? Basically, DFS means if we find a match, regardless of other matches that may exist from that root point, we will go as deep as we find all matches from that specific starting point. Now you see that we are already found all matches in grid in the right hand side, but not in the tree yet. In case of our tree, we will jump one step back and search for other possibilities. Then after we finished finding all matches for that starting point, we will move to the next one. The point here is we will go as deep as there's nothing else left, then move on to another portion. In order to implement this, we are going to need a stack because it follows the last in first out manner, and that is exactly what we want here as we go deeper and deeper in our input. In the other hand, breadth first search kind of works a bit different here. Again, if we happen to find a match, we will look into its first steps, scan them all for every possible match, and then move on to another depth that we found from our previous steps. And for that, we will use a queue, since we need to store all items in order and process them with the specific order that we added them into the queue. First in, first out. So back into our grid, this is the gist of what we are going to do with each of our islands. For every possible island that we find, literally every one, we will do a DFS or BFS search to find all neighbors, and of course respectively increase the number of islands. We will move into the next cell and look for another, but we also need to know that if we move to another cell, did we already count this cell as adjacent to the previous one or not? For that, we are going to need some sort of visited hash map or some kind of storage to keep track of those visited coordinates from grid and prevent from checking them again in future iterations. But since having a hash map can take up some space, we are just going to simply change their values to 0 as we do our DFS or BFS search. And by that, in the next iteration, we will automatically skip them because they are zeros by then, not ones, until we reach in here. Well, we have another one, that means another island. But if we start to look around, we don't see any island adjacent to this. Just remember that we are not allowed to look diagonal. We only need to look horizontal and vertical. Finally, at here, we need to mark that founding as 0, like that. Okay, back to the iteration. Now we will skip until our next one at here. We will increment islands count, of course. Then look for adjacent one. Yes, we have another neighbor here. Mark them as 0 like that, and we are finished with our iteration with 3 islands. That's simple. So here we are in leetcode. First we will implement the depth first solution and then move on to the breadth first, but both of them will have some shared code for grid traversal. We will start by defining our variable, the island count. We will do let island equal to 0. Then our double for loop, we will do for let r as row equal to 0, r less than grid dot length. It contains some arrays, and r plus plus. Then inside of that we will do for column, for let C as column equal to 0, C less than grid at index 0 dot length the first row and column plus plus. And inside of this we need to do or check. So if our grid at this row and at this column equal to string of 1, then we need to do some work here. First, we need to increment islands count because we just found one. Island plus plus. Second, we need to call our DFS search helper function, passing row, column, and entire grid as argument to it. So we will do DFS search, passing row, column, and grid for it. Now let's create that helper function. We will do const DFS search is going to be an arrow function. It will receive row, column, and grid. First thing we are going to do is resetting grid's value at that coordinate. So we are going to do grid at this row, and at this column we are just going to reset its value to 0. Then basically we will check for each 4 neighbors of that cell. So for up we are going to do if grid row -1 call is equal to 1. If that is the case, we are going to call this function DFS search and passing row -1 and call and grid again to it. The same thing will apply for down. So we will do down if grid row at +1 but in the same column is equal to 1. We are going to do DFS search passing row +1 column and grid. For left and right we are going to adjust the column, not row. So for left we are going to do if grid at this row but column -1 is equal to 1, then we are going to do search passing row column -1 and then entire grid. And for right we are going to do if grid at this row but column +1 is equal to 1. We are going to do DFS search with that respective coordinate call +1 and then grid. We are missing some important checks here. What if the cell was in the edge of our grid? So for each of those recursive calls we will adjust the logic a bit. For up this is going to be the case but only if row is larger than 0. Then we are safe. For down this is again going to be the check but only if row is less than grid that length -1. That is our safeguard here. For left we are going to play around with column. So if column is larger than 0 then do the or check. And for right we are going to do column is less than grid at index 0 dot length -1, and by that we are limited or recursive calls and they are safe to iterate through the entire grid. At the end just don't forget to return the islands variable of our main function, like return island. And now if I run this, test cases are passing, and if I submit, we are in a good shape. One note that I need to mention here is we did not use stack and directly called our recursive functions over and over while saying this is a DFS search. In fact, we can do something like const stack equal to an empty array, and in each of those if checks we can push only the coordinates into our stack. Like instead of this we can do stack dot push these coordinates in an array, and we don't need grid in this case. Now at the end we need to do a final while loop over our stack because we are not calling our recursive function, right? So we are going to do while as long as stack.length is a true C number. We are going to call our DFS search function and we would pop the last item from stack.pop and passing the entire grid here. Now if I run this it will still pass, and if I submit, and as you can see our memory usage is a bit high, but to be honest that is unnecessary work and we can skip it in this case, only relying on our recursive calls. For first solution, it is basically the same, but with a bit minor change in logic. We will still increment our islands variable inside of our if check in nested loops like island ++, but this time we will call our BFS helper function and again passing row, column, and grid to it. So we will do BFS search, passing row, column, and grid like that. Now let's create it below this function. We will do const BFS search. It's going to be an arrow function. It will will receive row, column, and grid. But first thing, we need to define our queue, basically an array in JavaScript. So we will do const queue is going to be an empty array. And initially, this queue will have our first coordinates with given row and column, because that is the first coordinate in our grid that contains 1 and has brought us to inside of this BFS search function. So we will do another array, row and column. Now, since our queue has something inside of it, we will do a while loop over that. So we will do while as long as queue.length is a true C value. We will pluck out the first thing we have in our queue by shifting first item from it. So we will do const, just destructuring row and column from queue.shift first item in the queue. And literally we will do some checks with minor difference. Here are same checks for up, down, left, and right. Now here is the checks that we needed to escape from edge case errors. So at this step, a minor difference between DFS and BFS solution pops out. And that is, we need to reset each row within its if check, because the order we put coordinates into queue and the way that queue works, first in, first out, kicks in here and could mess up the order of operation that we need to do. So we will push coordinates into our queue in each if case and immediately reset that coordinates value to 0. Okay, now for up, we will do queue.push inside of an array, row -1 at this call, and then we will immediately reset this coordinate to 0, not triple equal. For down, we will going to do the same, queue.push inside of an array, row +1 at this call, and then immediately again reset this, not triple equal. And again for left, we will do queue.push inside of an array, row but column -1, and immediately reset this to 0, not triple equal. And again, one last time for right, we will do queue.push inside of an array at this row, column +1, and set this as well. Like that. Now if I run this, everything is passing, and if I submit, we are in a good shape. Now let's jump back into the time and the space complexity analysis. For time complexity, we will have O of n by m because we are traversing our 2D matrix. Also, n is the number of rows and m is the number of columns. For space complexity, we also going to have O of n by m because think about the worst case where all matrix could be lengths. In that case, we will iterate once over our matrix and mark them all with zeros. With that, I can say that was it for this video, and make sure to subscribe to the channel in order to not miss out new videos. I also will put the link for arrays playlist in video's description where we go through solving some array problems from LeetCode. So thanks for watching, and please like, comment, and subscribe to the channel. And finally, hope you enjoyed this video and stay tuned for the next one.